morning to one and all. Welcome you all to the Thermodynamics course. So in today's lecture, we are going to discuss about steady flow energy equation. So in the previous lecture, we have discussed about basic law of thermodynamics, and we have applied those laws of thermodynamics to the closed system. But in today's lecture, we are going to discuss about the steady flow energy equation, which is applicable for the flow system, or we can say that is what the flow process. So first of all, what is meant by actually we are having a flow or a open system, right? And we are going to apply with respect to this flow system the steady process we are going to apply, and we are going to deduce the mass balance as well as energy balance equation. See, whenever if we are saying this is a flow process or open system, right? So there actually I am having the fluid inlet conditions as well as the fluid outlet conditions, right? So for the open system, we know that energy as well as mass transfer takes place. Right? We know that energy and mass transfer takes place. But whereas in the closed system, only the energy transfer takes place, the mass transfer won't take place. See, if the mass is transferring with respect to inlet and outlet conditions, what happen? We supposed to consider the other energy parameters also. See, whereas in the closed system, we have considered only the basic energy parameters, right? With respect to heat energy, internal energy change, and mechanical work done, right? But whereas whenever the flow process are there with respect to inlet and outlet conditions, then I supposed to consider all other energy parameters also. See, for example, we are having with respect to the flow system Q, and we have considered W and the internal energy change. What is it actually we are having? The internal energy change with respect to U2 minus U1. Right? That is only applicable for closed system. Whereas in the open system, I supposed to consider, in addition to this energy, I need to consider the inlet kinetic energy. See, this is with respect to wherever the mass transfer takes place, obviously the working substance velocity also we supposed to consider. So whenever the velocity of the working substance I am going to consider, certainly it should possess some kinetic energy, right? So that is what actually we supposed to consider in terms of V1. Assume the velocity V1, right? In some other textbook also they might have mentioned C1. So in either way you can consider, right? Because in thermodynamics V is nothing but the volume parameter, so better we'll go with the C, right? So the C1 is nothing but the inlet velocity, and C2 is nothing but actually we are having the outlet velocity. The difference between this inlet velocity and outlet velocity will get the change in kinetic energy, right? And similarly, we are having the inlet position, right, with respect to Z1 datum level, and the outlet position is nothing but actually we are having the Z2 datum level. So because of this, actually there is also actually we supposed to consider the change in potential energy. So with respect to Z1 we are having some potential energy that is applicable to inlet, and with respect to the outlet actually I am having Z2. So in this way we have considered. So the difference is nothing but actually we are having as change in potential energy. So what I am trying to say, for the open system, right, or we can say whenever the mass transfer takes place, so obviously I supposed to consider with respect to the kinetic energy and with respect to the potential energy, right, in addition to the closed system energy parameters. So the closed system energy parameters already we discussed: heat energy, work done, and we are having the internal energy change. So while discussing the closed system, we have come across with two work done parameter. One is nothing but flow work done, I said, and another one is nothing but we call it as displacement work done, right? So the displacement work done is nothing but wherever the displacements we are having. So in the simple mechanical work done is nothing but force into perpendicular distance. So this displacement wherever we are having, then I can able to sense the displacement work done, or we can say mechanical work done. But in addition to that, whenever we are having the flow, see the mass is actually flowing with respect to this particular device or particular control volume. So whenever the flow is taking place, obviously we are supposed to consider the flow work done also. Right? The flow work done. The flow work done parameter also I supposed to consider. Got it? So this flow work done is nothing but actually we are transferring the mass from one place to another place. So there also actually the displacement is taking place. But that is actually applicable with respect to the working substance, not with respect to the boundary. If it is with respect to the boundary, then we can able to say that this comes under mechanical work done. Right? So these are the energy parameters I supposed to consider for this flow, or we can say open system. Right? So this is introduction about the open system, right? And what are the energy parameters we supposed to consider? That is also primary one. Got it? See, but we are going to discuss with respect to only steady flow energy equation. Simply we call it as SFW equation. So there SFW in the sense steady flow. Flow is nothing but actually we have already considered open system. Right? So there actually I am going to consider only with respect to the steady rate. The flow occurs in terms of the steady way. Right? So we will discuss about that steady conditions, and after that we will enter into the mass balance equation as well as energy balance equation for this flow system, that too under steady condition. Right? So in our syllabus actually we are having only the steady flow processes. So we can able to apply with respect to the unsteady flow process also. But the steady flow process is nothing but for simplification purpose. For analysis purpose, the steady actually we can able to easily consider. That we can able to implement to the unsteady flow processes. Right? See here, the steady flow processes is nothing but a process in which matter and energy flow. Right? So the matter is nothing but the mass and energy. We are having various form of energy. Right? So energy transfer flows in and out of an open system at steady rates. At steady rates. So wherever the rates is given, steady rates is given, right? For example, mass flow rate, steady mass flow rate, right? Steady discharge rate. So wherever the rate, if I am mentioning, that is actually with respect to the time taken. Right? So open, see, out of an system at steady rates. Moreover, an open system undergoing a steady flow process does not experience any change in the mass and the energy of the system. So this is for the simplification actually. So I have considered the flow system, mass transfer is taking place, right? And the energy transfer is also taking place. But even though for the steady flow process, right, it does not experience any change in the mass. So what are the mass I have considered before starting the process, right? So after ending the process also, we are having the same mass over there, right? So this phenomenon is nothing but actually similar to the closed system. In the closed system also we have considered mass equal to 1 kg, right? So for example, we have considered. Similarly over here also we have considered mass equal to 1 kg, but we are having the flow work done, right? So these energy parameters I supposed to consider. Got it? So that is why for simplification purpose we are having this steady flow processes. Got it? So which means there is no any change in the mass and the energy of the system before and after the process. That is why we have considered this basic simple steady flow processes. Right? So then we have mentioned that the system is at steady rates. Right? So what is that steady rates? How we are saying that it is having with respect to the steady rates. Right? So what does that actually denotes? So for that actually, see the term steady implies always no change with the time. So that is what the steady rate actually we are having. Wherever the rate is mentioned actually, that is with respect to time. For example, So there is no change. What is there is no change actually? With respect to the macroscopic property, with respect to the thermodynamic macroscopic property, right? With respect to the energy parameters. So if I'm considering there is no change with respect to the thermodynamic property with respect to time, then I can able to say the flow process comes under steady rates, right? So that is what we have given. See, we can able to say a person running at a steady speed of 5 km per hour. So this might be the average one, right? So during 10 minutes, he might have run with respect to 6 km per hour, right? And after 10 minutes, he might have run 4 kilometers per hour. So the average actually, we call it as actually 5 km per hour. So for every hour, for every 1 hour, what happen actually? He reaches 5 km. The first hour, right? The first 1 hour, he reaches the 5 km. And the next 1 hour actually, he will reaches the again 5 km. So total 10 kilometers he can able to cover. This is what actually we call it as steady. So with respect to time taken, right? Here the speed is nothing but actually we call it as the parameter or property, right? So for example, I have taken the speed, right? So this is what actually we are having the steady rate actually. This is not what is steady. This is what a steady rate we are having, right? See, with respect to these thermodynamic properties also I can able to say. See here, with respect to the thermodynamic property, we have taken with respect to the good example as the first one. See, that is what with respect to the time taken. So during 10 a.m. I have measured with respect to this pipeline, right? I measured the with respect to different points. I have measured the different pressure, right? So P1, P2. This is with respect to 0.1, 0.2, 0.3 and 0.4 and 0.5. So these are the examples that we have given, right? See, after 4 hours, right? So during 2 p.m. also, if I measure the pressure parameter with respect to the same pipeline, with respect to the same point, if it denotes the same value, more or less, then we can able to say the process, right, flowing through this pipeline is nothing but is steady rate, right? So with respect to time taken, they have considered steady rate of 0.3 kilogram per second, right? So this is entering the system and this is leaving the system. So this pipeline is nothing but right now your system. So entering the system is nothing but actually 0.3 kilogram per second and leaving the system is also nothing but 0.3 kilogram per second, right? So entering is nothing but always 1 with respect to suffix 1. So mass flow rate or water flows at a steady rate is nothing but m dot 1, which is equal to m dot 2. 2 denotes always with respect to the leaving the system, right? So this is what actually we call it as the steady rate. So this example actually we can able to consider for the thermodynamic properties, right? So we have displayed only with respect to the pressure, right? See, what are the characteristics of steady rates actually we are having, right? So already we discussed that in the steady rate we are having there is no change in the mass within the system and there is no energy changes within the system, right? So with respect to that characteristics actually I can able to solve the more numerical problem in the real time, right? So for that purpose actually we have framed the steady flow energy equation. See, the characteristic 1 is nothing but actually we are having no property at any given location within the system boundary changes with respect to the time. That already we discussed, right? So no property, no thermodynamic property, no macroscopic thermodynamic property. For example, pressure I can take, temperature I can take, right? And volume I can take. So with respect to the time taken, so these properties at given locations, right? With respect to the given locations, right? Within the system boundary, it doesn't changes. That is what the first characteristic, right? See here, because of this actually what is happening, the total volume V of the system remains a constant. So with the example actually I can able to say, the total mass M of the system remains constant and that the total energy E, of the system remains a constant. Then I can able to say this is nothing but comes under steady flow process. Got it? So this is your first characteristic. So these are all actually I can able to implement with respect to the governing equations. In order to frame the governing equations, these are all the conditions I can able to use, and with that I can able to apply to the real time applications also, right? See, and the next characteristics is nothing but actually, since the system remains unchanged with time during a steady flow processes, the system boundary also remains the same, right? So that is what the total volume actually we have given. So with respect to the total volume, always the system boundary also remains the same. Got it? So which means whenever if the boundaries are keep on changing, right, then I supposed to consider for the unsteady flow processes. So this is very simple for the steady flow processes, right? That is what given. And the next characteristic is nothing but, see, no property at an inlet or at an exit to the open system changes with time. See, that is what the first character actually we discussed with respect to the total one. Total one, the system, along with the inlet and outlet, we have considered everything as a system, right? So here actually the no property at an inlet or at exit to the open system changes with respect to the time taken. There actually I said only volume and mass and the energy parameter. Here actually with respect to the inlet rate also we can able to say mass flow rate to the inlet. That is what we discussed, right? So this is the characteristic 3, right? See here the mass flow rate we are having, the energy flow rate we are having, and with respect to the pressure, temperature and specific volume also we are having, right? So these are the examples actually we can able to consider with respect to the steady flow processes, right? So the velocity of flow at an inlet or at an exit remains constant throughout the process. Before starting the process and after completion of the process also, these parameters are remains constant. Then only we can able to say that is nothing but steady conditions, right? So these are the various characteristics actually we have discussed, and this is about actually the basics of steady flow process, right? That steady flow process we have applied to the open system, right? So in the next lecture we will discuss about mass balance as well as energy balance equation for this steady flow processes. So thank you one and all. We'll see you tomorrow.